Hello students, welcome to Deeksha Online Mathematics. Let us discuss some problems on trigonometry. Problem number 1, 2 sine 2 degrees plus 4 sine 4 degrees plus 6 sine 6 degrees plus so on 180 sine 180 degrees is equal to k cot x, then k plus x equals to. You know that sine 180 degrees value is 0 and sine of 180 minus theta is equal to sine theta. So 2 sine 2 and the last but one term 178 sine 178 will become 178 sine 2. In middle there will be 90 sine 90 degrees. So if we simplify this, 180 times you will have sine 2 degrees plus sine 4 degrees plus so on sine 88 degrees plus 90. This is a series where angles are an arithmetic progression. We have a formula, alpha equals to 2 and beta is the common difference, that is also 2, and number of terms are 44. So let us use the formula sine n beta by 2 by sine beta by 2 into sine of alpha plus n minus 1 into beta by 2. So you will get 180 times sine n beta by 2, which is 44 degrees, by sine beta by 2, that is sine 1 degree, into sine of alpha plus n minus 1 into beta by 2, that is 43 plus 90. So if you simplify, you will get 90 times 90, I am taking common, 2 sine 44 into sine 45 by sine 1 degree plus 90. Okay, I am taking 90 common, so I'll write here 1. So 2 sine A sine B, which you can write cos difference minus cos sum. Cos sum will be cos 89, which is equal to sine 1. So if you simplify this as 90, that 1 gets cancelled, 90 cot 1 degree you will get. So the value of k is 90, and here I asked x. Suppose if it is x degrees, x value will be 1, then your k plus x value will be equals to 91 if x is in degrees. Suppose if we take it as a radian, that x value will be 1 degree will be how many radians? That radians you have to use. Generally, whenever units is there, if it is degrees, we will mention it is degrees. If it is not mentioned, we take it as radians. Okay, here take this as degrees, x degrees, then k plus x value will be 91. But here k is this quotient 90, x degrees, so x value is 1, so 91. Let us go to the second problem. In triangle ABC, if cos A cos B cos C is equals to 1 by 3, then tan A tan B tan C times cot A plus cot B plus cot C is equals to how much? So in triangle we know that A plus B plus C is equal to 180 degrees. So what will be cos of A plus B plus C, which is -1. So cos of A plus B plus C, we know cos A cos B cos C times means 1/3 times 1 minus T2 equals to -1. From this, T2 value will be 1 plus 3, which is 4. Now if you observe the given question, it is nothing but T3 into C1. T3 into C1 is nothing but T2. So T2 value is 4. So the answer is 4. Let us go to problem number 3. If x square plus y square is equal to x square y square, then what is the range of xy divided by 5x plus 12y plus 7xy? Here, if it is range, okay, but if it is minimum maximum values, students will confuse here. Let us see how we solve this question. Observe this condition. X square plus y square is x square into y square. So sum is equal to their product. So let us assume x is secant theta, y is cosec theta. Because we know that secant square theta plus cosec square theta is equal to secant square theta into cosec square theta. Let us use these two values in the question. So it is secant theta into cosec theta divided by 5 secant theta plus 12 cosec theta plus 7 secant theta cosec theta. Then the question is, so if we divide both numerator and denominator with secant theta cosec theta, it will be 5 sin theta plus 12 cos theta plus 7 whole to the power of -1. So you know that a cos theta plus b sin theta plus c range is c minus root over a square plus b square to c plus root over a square plus b square. Here 7 minus 13, that is -6, to 7 plus 13, that is 20, to the power of -1. Means this is a range of this. I want its reciprocal. So actually what happens if the question is, instead of range some maximum value, suddenly students will say 1/20, minimum value -1/6. But whenever in this region, if you have -1 to 1 region, their reciprocals, -6 to 20 reciprocals, because -1 to 1 region reciprocals will go to -infinity to -1 union 1 to infinity. Whenever in this range, this region is there, we should be very careful in writing the range. So its reciprocal range will be -infinity to -1/6 union 1/20 to infinity. So this is the range for the given question. Observe carefully. If they ask instead of range what is the minimum, what is the maximum, there is no minimum, there is no maximum for this. So suppose if this 5 sin theta plus 12 cos theta plus 7, instead of that, suppose if we have something whose range does not contain this -1 to 1. Then suppose like example some 3 to 7 reciprocal I want. Then it will be 1/7 to 1/3. Please observe carefully. Whenever this -1 to 1 region is there, then while writing the reciprocal range, you should be very careful. Let us move to next problem. Problem number 4. If cos of a minus b plus cos of b minus c plus cos of c minus a is equal to -3/2, then I want the incenter of the triangle formed by these vertices cos a comma sin a, cos b comma sin b, and cos c comma sin c. Let us observe given condition. This is the given condition. Cos of a minus b, so cos a cos b plus sin a sin b, plus cos b cos c plus sin b sin c, plus cos c cos a plus sin c sin a. Let us cross multiply. So what we will get? 2 cos a cos b plus 2 sin a sin b. Like this we will get. Similarly, 2 cos b cos c plus 2 sin b sin c plus 2 cos c cos a plus 2 sin c sin a is equals to -3. That -3 I'll send to the left side. It will become +3. Then this side will become 0. This +3 I will write as 1 plus 1 plus 1. Each one I will write a trigonometric identity: cos square a plus sin square a, cos square b plus sin square b, cos square c plus sin square c. So that if you observe the left side, it is very clearly cos a plus cos b plus cos c whole square plus sin a plus sin b plus sin c whole square is equal to 0, because cos square a plus sin square a 1, cos square b plus sin square b this 1, cos square c plus sin square c 1. So 2 cos a cos b, 2 sin a sin b. Like that all terms are there. So something square plus something square is 0 means each will be 0. Means the sigma cos a will be equals to sigma sin a, that will be equal to 0. Now let us come back to our question. What is the question? There is a triangle with these vertices cos a comma sin a, cos b comma sin b, cos c comma sin c. If you observe carefully, the three vertices are equidistant from origin. Suppose if I name this as PQR, this PQR are equidistant from origin because cos square plus sin square, distance formula, each is equal to 1. So circumcenter of this triangle PQR will be origin. Now let us find its centroid. What will be the centroid of this? Cos a plus cos b plus cos c by 3, sin a plus sin b plus sin c by 3. But according to given condition, we got that is also origin. So the triangle has same circumcenter and centroid. So it must be equilateral triangle. Now if it is incenter also, origin will be the incenter. Let us go to the next problem. Okay, let us solve this problem. Under root of 1 plus sin a plus under root of 1 minus sin a is equals to 2 cos a by 2. Then we have to find the region for a by 2. So you know that under root of 1 plus sin a as mod of s plus c, out of 1 minus sin a as mod of s minus c, and I want the answer to be 2c. So to get 2c, this should simplify as s plus c, and this should simplify as c minus s. Then only you will get 2c. Mod of s plus c will be s plus c if s plus c is positive. Mod of s minus c will be c minus s when s minus c is negative. Then if you remember the diagram, recollect that s plus c, s minus c diagram. 2n pi minus pi by 4 to 2n pi plus pi by 4. This is the fourth region where s plus c will be positive and s minus c will be negative. So your a by 2 belongs to that region 4, 2n pi minus pi by 4 to 2n pi plus pi by 4, union n belongs to set. If capital A is equal to tan 20 degrees plus 4 sin 20 degrees, and capital B equals to tan 6 degrees tan 42 degrees, and capital C is equal to cot 66 degrees cot 78 degrees, then AC divided by B. So we have to calculate A into C divided by B. Okay, let us see first the value of A. Tan 20 plus 4 sin 20. Tan 20, if we write sin 20 by cos 20 and take LCM, it will be sin 20 plus 2 sin 20 cos 20 is sin 40 divided by cos 20. Now 2 sin 40 you write as sin 20 plus sin 40 plus one more sin 40 by cos 20. Sin C plus sin D, transformations formula. 2 sin C plus D by 2, 30 degrees, cos C minus D by 2, 10 degrees. Sin 30 is half, so I am cancelling, so cos 10 is left over. I'll convert this as cos 50 divided by cos 20. Again the formula is cos C plus cos D, 2 cos C plus D by 2, 30, cos C minus D by 2, 20, by cos 20. So cos 20 gets cancelled. So capital A value is root. And observe B and C very carefully. The angles used there are 6, 42, 66, 78. And one is tan function, one is cot function. So what I will do, to convert into same function, I will take B by C value. Then it will be tan 6, tan 42, tan 66, tan 78. Observe 6, this is 60 plus 6. So for the formula, tan theta into tan 60 degrees plus theta into tan 60 degrees minus theta is equal to tan 3 theta. 60 plus 6 is available, 60 minus 6 tan 54 is missing. Let us multiply and divide with that. And observe other two angles, 42 degrees and 78 degrees. If you observe carefully, this is 60 minus 18 degrees and this is 60 plus 18 degrees. So if I write what are missing, tan 6, tan 66, tan 54, because for the formula I multiplied, so I am compensating it by dividing. Tan 18 into tan 42 into tan 78 by tan 80. Compensation. Here I multiplied, I am dividing. So by the formula, this is tan theta tan 60 plus theta tan 60 minus. It should be tan theta tan 60 plus theta tan 60 minus theta. So it should be tan 3 theta, means tan 18 degrees. This gets cancelled. Tan theta tan 60 minus theta and tan 60 plus theta. So tan 3 theta, 18 is a 54. So this gets cancelled. So B by C value is equal to 1, means B and C are equal. So in our question, AC by B, this C and B gets cancelled. The question remains as A value is root 3. So the answer is root 3. Okay, let us go to problem number. Okay, let us see problem number 7. If sin cube x sin 3x is equal to sigma m equal to 0 to k cm cos power mx, that is equal to sigma n equal to 0 to L Cn cos nx, where ck and cl are not equal to zeros. The number of onto functions from set A to set B, where n of A is k and n of B is L. Okay. Now sin cube x sin 3x, if you observe this carefully, they want to express sin cube x into sin 3x as cos powers. So let us write sin cube x into 3 sin x minus 4 sin cube x. 3 sin power 4x, which is 1 minus cos square x whole square minus 4. Sin power 6x, which can be written as 1 minus cos square x whole cube. So if you expand this, you will get one expression. But what is our question? If you observe carefully, they want expansion from m equal to 0 to k, means c, c0, c1, c2 up to ck, where this ck is not equal to 0. Means you should expand up to that ck not equal to 0. If you observe carefully here, the highest power you are getting is 6. So that should be the value of k. So k value must be 6. Similarly, if you observe this now, same sin cube x into sin 3x. Now we have to express in cos multiple angles, cos nx. So let us write this as 1 by 4 sin cube x. This I am writing 1 by 4 sin cube x. The 4 sin cube x can be written as 3 sin x minus sin 3x into sin 3x. If you expand this, 1 by this 3 by 4, this is 3 by 8 I am writing, 2 sin x sin 3x minus 1 by 8 I am writing, 2 sin square 3x, this is square. So by using transformations, you can write 3 by 8, 2 sin A sin B cos a difference minus cos sum. 1 by 8, 2 sin square 3x is 1 minus cos 6x. So again, if you observe, this is c0 cos 0x plus c1 cos x plus c2 cos 2x, so on. So the highest is again 6 here. So the L value is moving up to 6. So here n of A you have 6 elements and n of B you have 6 elements. And I am asking number of onto functions. It is nothing but bijections, because n of A equals to n of B. So which is 6 factorial, which is equal to 720. Let us go to the next problem. I want number of solutions of the equation sin x plus sin y equals to sin of x plus y and mod x plus mod y equals to 1. I think this, mod x plus mod y equals to 1 will have 4 cases, x positive, y positive. So you should get a straight line in first quadrant. If x negative, y positive, second quadrant, x negative, y negative, x positive, y negative. So you should get a square. Now if you observe this equation, sin x plus sin y is 2 sin x plus y by 2 cos x minus y by 2 is equal to 2 sin x plus y by 2 cos x plus y by 2. So bring left side and take common. Sin x plus y by 2 times cos x minus y by 2 minus cos x plus y by 2, cos difference minus cos sum, 2 sin a sin b equal to 0. So x plus y must be equal to 2n pi, or x equals to x by this must be n pi, or this must be n pi, or this must be n pi. So either x plus y is 2n pi, or x equals to 2n pi, or y equals to 2n pi. Now if you give n value integers, if n is 0 here, x plus y is 0, which is y equals to minus x. So there are two solutions in that case. If n equal to 1, I think it is crossing the square. Here if n is equal to 0, x equal to 0, y axis. So these are the two solutions. For other values of n, it is crossing the square. Means it is not intersecting the square. Here also, if n is 0, it is x-axis. Two solutions. For other values of n, it does not meet square. So the total number of solutions are 6. Let us go to the next problem. The number of distinct real values of the parameter a, for which the equation integral 0 to x sine squared t by 2 dt is equal to a square x square minus of 3x minus 1 whole divided by 2 plus 1 by a square, possesses a solution or root, real root, in the interval 0 to 4 pi. This equation should have a solution in 0 to 4 pi. For that, what are the distinct real values of a? That is the question. So first, if you do the definite integration, the sine squared t by 2, you can write 1 by 2 into 2 sine squared t by 2, which is integration of 1 minus cos t by 2, which is equal to from 0 to x, which will be the given is a square x square minus 3x by 2 minus into minus plus 1 by 2 plus 1 by a square. So this is half definite integration. If you apply half x minus 1 by 2 cos t is integration sin t, that is sin x minus sin 0, so half sin x equal to same. Now if you simplify this, you will get sin x equals to, this 2 gets cancelled, minus 1 minus 2a square x square plus 4x minus 2 by a square, then which is nothing but sin x is minus 1 minus 2. If you take common, you can write ax minus 1 by a whole square. Observe that final equation which you got. As you know that sin x range is minus 1 to 1 closed, and this is a perfect square having a minus 2 as the coefficient. So this quantity will be always negative. So for the validity of this equation, sin x must be equal to minus 1 and ax must be equal to 1 by a. So the value of x must be equal to 1 by a square. Means this x value must be 1 by a square. So sin of 1 by a square equal to minus 1. So 0 to 4 pi means x value must be minus 1 by a square and its value must be minus 1. So 0 to 4 pi means 2 rotations. This is 2 pi, this is 4 pi. Minus 1 is possible on negative y-axis. Means x will have two values. So 1 by a square will have two values. So a will have 4 real and distinct values. Okay, let us go to the next problem. The number of non-similar isosceles triangles possible such that tan A plus tan B plus tan C equals to 100 I want. Okay, so let us assume, since it is isosceles, let us say angles A and C are equal. This will give you angle B will be equals to 180 minus A minus C, which we can write 180 minus 2A. Now let us use these conditions in the given equation. So you will get tan A, tan B is tan 180 minus 2A, which is minus tan 2A, plus tan C is again tan A, which is equals to 100. So this implies it is 2 tan A, and tan 2A formula is also 2 tan A by 1 minus tan square A equals to 100. So 256 gets cancelled, take LCM and cross multiply. You will get tan cube A minus 50 tan square A plus 50 equal to 0. Okay, now let us assume tan A equal to x. Then let us have a function f of x equals to x cube minus 50x square plus 50. It's a cubic equation. So if we calculate f dash x, which will be 3x square minus 100x. So the critical points we observe 0 and 100 by 3. So if you take the number line, 0 and 100 by 3 are the critical values. And if you observe carefully, from minus infinity, our f of x value is negative, and at 0 it is 50, which is positive, and at 100 by 3 f is negative, so should be a continuous and it is coming down. So you have two roots here, one is negative, one is positive. Since it's a cubic equation, other root must be there, a real root only. So this cubic equation will have three roots here. But don't forget that our x is tan A. So if x is a negative root, that is tan A is negative. If tan A is negative, the triangle is not possible. So this is ruled out. This solution is ruled out. Then you can have two positive values for tan A, which are possible. So number of isosceles triangle are 2. So number of non-similar isosceles triangles which are possible are 2. Let us go to the next problem. If A comma B comma C are distinct and are of same sign, they are distinct and are of same sign, then cot inverse AB plus 1 by A minus B plus cot inverse BC plus 1 by B minus C plus cot inverse CA plus 1 by C minus C equal to how much? So generally in hurry, students will think that this cot inverse can be written as tan inverse A minus B by 1 plus AB. So which is tan inverse A minus tan inverse B, and this is tan inverse B minus tan inverse C, and this is tan inverse C minus tan inverse A. So everything gets cancelled. They will say answer is 0. But you think, it's simple common sense, cot inverse range is open interval 0 to pi, open interval. So cot inverse cannot take 0, and we are asking sum of 3 cot inverse and we are saying 0. So which is impossible. So what is the logic in this problem? They said that A, B, C are distinct, are of same sign. Why they are saying they are same sign? The products AB, the products BC, the product CA must be positive if they are of same sign. And A minus B plus B minus C plus C minus A, this sum is always 0. When their sum is 0, there are two possibilities. That is, this A minus B, B minus C, C minus A. There are 3 quantities whose sum is 0. So the two possibilities are, among these 3, 2 can be positive and 1 must be negative because the sum must be 0. Or 2 can be negative and 1 must be positive. They are the two possibilities. So what is this 2 positive? Among the 3 quantities A minus B, B minus C, C minus A, 2 can be positive and 1 negative, 2 negative, 1 positive. Why we are discussing this? If you remember, cot inverse x, if you want to write as tan inverse 1 by x, you should see about this quantity whether it is positive or negative. There is a given condition, same sign, the numerators are always positive. And here we got that this A minus B, B minus C, C minus A, among those 3, these are the 2 chances. This one chance, this one chance. In this case, when 2 positive are there, in converting those 2 into tan inverse, there is no problem. Whereas converting that negative one, pi plus will come. That's why in this case, you will get pi plus the tan inverse of plus tan inverse of plus tan inverse of, which will be 0. It gets cancelled, but not simply as we discussed it first. First, by converting cot inverse, 1 pi will be generated because of this 1 negative. So answer is pi in this case. In this case, since 2 negative, there will be 2 pi's and 1 cot inverse will be converted into tan inverse. Then all tan inverse will get cancelled. Your answer will be 2 pi. So for this question, you can have pi or 2 pi as the answer. Let us go to the next problem. Okay, problem number 12. 2 cos inverse x is equals to sin inverse 2x root 1 minus x square. Then x belongs to. So left side you have 2 cos inverse x and right side you have sin inverse 2x root 1 minus x square. So let us convert cos inverse x as pi by 2 minus sine inverse x. So which is equals to sine inverse x, sine inverse of 2x root 1 minus x square. 2 into pi by 2 is pi is equal to 2 sine inverse x plus sine inverse 2x root 1 minus x square. So if you remember, while discussing the synopsis, in between minus 1 by root 2 to 1 by root 2, if we take this as a and this as b, I told here a equal to b, here a plus b, I'm sorry, this is minus 1 to 1 because it is sine inverse x, so x should be between minus 1 to 1. So here a plus b equal to pi, here a plus b equals to minus pi. So here we got a plus b equal to pi, so x belongs to close to 1 by root 2 to 1. But there are several ways to solve this. This is one of the way we can solve. By learning that outputs of inverse trigonometric functions, we can solve like this. Okay, let us go to the next problem. Problem number 13. Cot inverse 2 plus cot inverse 8 plus cot inverse 18 plus so on up to infinity is k pi by 4. Then what is the value of k? Let us observe. This cot inverse 2, 8, 18, if you observe carefully, it is 2r square, where r equal to 1, 2, so on. So if it is 2 into 1 square, 2 into 2 square, 2 into 3 square, like that. So I can write the question as limit n tends to infinity cot inverse 2r square summation r equal to 1 to n. So let us observe this now. As 2r square is positive, I can write that as cot inverse as, let us convert into tan inverse. Tan inverse 1 by 2r square, which can be written as tan inverse 2 divided by 4r square. So that tan inverse 2, I am not writing, first 4r square I will write 1 plus 2r plus 1 into 2r minus 1, which is 4r square minus 1, 1 gets cancelled, is 4r square, and this is 2r plus 1 minus 2r minus 1, so which is 2. So tan inverse of x minus y by 1 plus xy, which we can write tan inverse 2r plus 1 minus tan inverse 2r minus 1. For this, let us apply sigma r equals to 1 to n. So what we will get? It will be tan inverse 1 means 3 minus tan inverse 1 plus tan inverse 5 minus tan inverse 3 plus so on, tan inverse 2n plus 1 minus tan inverse 2n minus 1. Now there is a telescopic cancellation. So the leftover are tan inverse 2n plus 1 minus tan inverse 1. Again, if you apply the formula, it is tan inverse of 2n plus 1 minus 1, 2n by 1 plus 2n plus 1 into 1, 2n plus 1. So which is 2n plus 2, 2 take common, it will be tan inverse of n by n plus 1, which can be written as 1 plus 1 by n gets cancelled. As n is tending to infinity, this is 0, then it will become tan inverse 1, which is pi by 4. So k pi by 4, so the k value is 1. So for this problem, k value is 1. Okay, let us go to the next problem. Let f be a function from closed 0 to 4 pi to closed 0 to pi and defined as f of x equals to cos inverse cos x. Then I want the number of points in 0 to 4 pi satisfying this f of x is also equal to 10 minus x by 10. So you know that cos inverse cos x, cos inverse of cos x is x, yes, but when this x is as some interval, means this cos inverse will remove this cos if this cos is a bijection. So this x must be equal to 0 to pi. So you know how to draw the graph for this from 0 to 4 pi. So it is x from 0 to pi, then pi to 2 pi, 2 pi to 3 pi, 3 pi to 4 pi. This is a graph of cos inverse cos x in this domain. Then the same f of x you have 1 minus x by 10 also. So if it is y minus 1 equal to minus x by 10, you know that y equal to minus x will be like this, y equals to minus 1 by 10 more some slope, and y minus 1 a shifting will take place. So a shifting on the positive y-axis 1 unit. So the graph will be like this. So the point of intersections, if you observe, here 1, here 1, here 1. So the number of points in between 0 to 4 pi are 3. Okay. So I've discussed trigonometry, some synopsis points. As you are the students preparing for advanced, I did not revise all the basic issues. Some things where we have to concentrate I discussed, and some problems I did, how to use that concepts. So practice them, learn all the formulas, try to use them so that you can save your time in the exam. All the best. Thank you.